Alright, stat students, this video is for both distance learners and in-person learners because you're all out for a couple weeks while everybody EOCs are happening. We're going to be starting the for dual credit. Now AP, you still have maybe two more sort of big concepts that we have to get through, but dual credit, this is the last chapter that we need to be prepared and to complete the content to take the dual credit exam. Okay, I did send out details about the dual credit exam. If you have any questions, make sure that you ask. But we're going to be talking about scatterplots today, so let's go ahead and get into it. Alrighty, so start a new page in your notes. You will need your calculator, by the way, so make sure that you go ahead and grab that, have it handy, plug it in if you need to. But we're going to be talking about scatterplots and correlation. It's kind of weird how we've gone. We started with chapter 4, then we went back to 1, 2, then 5, 6, 7, 8, 9, and now we're going back to chapter 3. And the reason that we do that is it's kind of disjoint from a lot of the other content. The rest of it kind of flows smoother that way. But this chapter we sort of always save to the end. And I will say this, compared to the other chapters we've been doing, this one should be fairly easy in comparison. Okay, it may not be easy, but compared to like hypothesis tests that we just did, this should not be too bad at all. Okay. Besides, you've probably already made scatterplots before at some point in your high school, or excuse me, in your math career at some point. I almost guarantee you've made scatterplots, whether it's in iMath or maybe even middle school you made them. But we're going to dive a little bit deeper than what you would have done in those classes. So go ahead and title your notes. It's Unit 9 here, Chapter 3, Scatterplots and Correlation is what we're going to be talking about. Now, you may have heard of this word correlation before, but we're really going to describe what it means. So my goal is to just teach for 30 minutes. Stop. I'll have another lesson tomorrow for about 30 minutes as well. And that's going to be sort of the pacing of what I've got. I do want to go ahead and show you, I've got up the problem set here. This one is quite lengthy. You'll see this, I'll have this uploaded on Kidum. It's got 62 questions, but I would say a lot of these are pretty straightforward questions. Some of them are going to be challenging, but for both dual credit and AP, this is what we're going to be working on. There may be some other like worksheets that we'll be adding in there, but our goal is to finish this content by the 23rd. So it's the 15th today. We'll have this content done the 23rd. There's not going to be a test over this. Your major assignments will be problems that we'll be working through sheets and practice, and then of course this problem set, which has always been a grade. And for dual credit, this is the final problem set. How about that? We made it. Right, we have made it. All right, so there's two things that we want to talk about first. Okay, so in your notes down below, you're going to, and a lot of this is going to be coming from lecture slides today, but we want to go ahead and write down response variable and explanatory variable. These two definitions. Now you've probably defined these before. Okay, I'm going to pause it and make sure that you get them both written down very quickly. A response variable measures an outcome of a study. An explanatory variable may help explain or influence changes in a response variable. And I put in here explains or causes. So the explanatory variable explains, right? And it's not like it guarantee explains. It may not, right? It may not. But that's what we're trying to show. So this is very much like an experiment. So go ahead and write these down. Okay, so an important note here is the goal in many studies, if we were trying to show causation, right, like one variable affects another, we want that explanatory variable. It's almost like that treatment, right? We say there's a treatment, and we talked about that in chapter 4, very beginning of the year. The treatment would be the explanatory variable that is actually causing changes, right, in a response variable. However, other explanatory response relationships don't involve direct causation. So that word causation is going to come up a lot in this chapter. And remember, causation is very difficult to prove for observational studies, but in experiments it can be proven. So if we're dealing with an experiment, causation is a very very much a reality that can happen. Okay. So we're going to be talking about scatterplots. So you can draw a line in your notes. That first thing, well, actually, let's talk a little bit more about these response and explanatory variables. I want to look at this first question here. So we've got this question, and the first few questions are going to be identify response or explanatory variable. Let's go look at the topics down here. Yeah, explanatory response. So you've got 3, 1, 4, and 5. If you just want to write that in your notes, you're defining those explanatory and response variables. So as you're reading these questions, you're always trying to decide, okay, which one is the response, right? That is, and which one is the explanatory? Which one is explaining the other in a way, right? So the height in feet and it says the height in feet and volume in cubic feet of a usable lumber of 32 cherry trees are measured by a researcher. The goal is to determine if the volume of usable lumber can be estimated from the height of the tree. Okay. In this study, the response variable is which one? Okay. So what let's I'm going to pause actually and let you guys multiple choice see if you can get it right. All right, so you had a chance to answer this, and for this one, it should be B, volume. That is the response, right? The volume of usable lumber. Okay, that's what they want. So the height, we're hoping, is going to explain that volume, which kind of makes sense, right? So here's another interesting tidbit when we're talking about these scatter plots. So here we have a scatter plot up here, and how it can help you determine the difference between them. So we've got scatter plots up here. And this bullet point here, so we're gonna pause and write all of this, but I'm gonna talk through it first. So a scatter plot shows the relationship between two. This is important. Two, and we need to bolden that and underline it. This is very important. These have to be quantitative variables. So I can't do height and gender, right? And you may see a question like that, or you may see answer choices. Let's actually go back and look at this. This is quantitative, quantitative, quantitative. The measuring instrument used to measure volume, that's impossible because that's not a numeric value, right? So that's what we're talking about when we say quantitative. Okay. Let's talk about how to make a scatter plot really quick, and then we'll pause and write this. So here's the scatter plot, and we're going to be making one of these today here shortly. I've got an example. This is that SEC football example. So first thing that has to happen, you have to decide which variable should go on each axis. This is the big bullet point that helps us a lot of times when we're looking at a scatter plot. The explanatory variable goes on the x-axis. And think of the explanatory variable as the input a function. So we're going back to sort of some algebra concepts here. This explanatory variable is the input, the response is the output. So think input, output, making a function, right? If I plug in a height, I should get out this response, this volume, this y, right? So label and scale your axes, plot individual data values. Okay, we're gonna have a computer do all of that for us. We're not gonna be doing it by hand. Maybe you did it by hand. There's a lot of teachers in middle school that do this, and that I've seen. And I think I've taught a lesson myself in a middle school once where I created these. So this is not a brand new concept to most of you. Okay, but that's the big idea. Okay, that is the big idea. And apparently on 4 and 5, you get to practice explanatory and response variables again. But it's going to be very important to determine which is which. And I think that these bullet points, which I didn't pause it yet, are going to help you. So I'm going to pause now. All right, let's make a scatter plot. We have an example here. So draw a line in your notes and write SEC football. Wait. SEC football. So we'll zoom in here. Actually, let me do this. this so we can just really see everything. Okay, so SEC football. So this data comes from 2011, the college football season, and Alabama and LSU were in the national championship. This is before they were doing the playoffs. Interestingly, both of these teams were from the SEC. Here are the average number of points scored per game and number of wins for each of the 12 teams in the SEC. So we can see all of these data points. Okay. So we want to make a scatter plot of the relationship between points per game and wins. So I'm going to zoom in on this data here. And the first thing that I want to do is I want to ask you which one would be the explanatory and which one is the response. And really I'm just going to say, I'm going to pause it here, and you're going to answer this. I'm going to say which one of these variables, points per game or wins, is the explanatory variable. Which one is explaining the other? Okay, so I'm going to pause and let you decide that. All right, so hopefully you answered correctly. And you'll notice that the points per game should correlate, I won't use the word correlate yet, but should explain the wins that they're getting, right? So the points per game is the explanatory. I'll put an E by it, both of these. And the wins is the response, okay? Okay, that's those are going to be our variables. Okay, now it's time to create a scatter plot with this data, okay? So what you're going to do is you're going to turn on your calculator. You're going to create a new document, don't save, and you want to do a list and spreadsheet. So this is all very familiar to us. We can do a couple things here. I like to put X and Y for this, just so that I remember which one is the explanatory and which one is the response. Because that's going to be, and when we go to graph the scatter plot, we'll remember. But for now, I'm going to put PPG, points per game, and wins. Okay, we're going to do that for now, so we can practice memorizing which one goes where. Okay, so let's go ahead and enter in all this data. I'll pause the video right now so that you can enter it in. Hopefully you can see it on the screen pretty easily, all of these data points. So every single explanatory variable goes in the points per game. And then they need to be lined up and associated. So if I put 34.8 here, I have to put 12 here. This represents Alabama, right? So they have to be matched up appropriately, okay? They have to be. So make sure that you do that. All right, let's go ahead and pause and fill this in. All right, so I've got mine filled in. It should go down to 12 here. We got that, okay? Now, it's time to make the scatter plot. In general, on tests, you're not gonna have to draw these by hand. It's not gonna be an issue, okay? So we're going to, we can always create them on our screens and on our, if you have a computer even, you can do it in Excel, but of course on our tests, we're gonna be using our Inspires. You're gonna have to add a new page, so go ahead and hit Control, Doc, and we want data and statistics here. Okay, now it's time for us to set our variables. So at the bottom, and we've done this plenty of times, we've always used this bottom one, and I'm sure some of you have messed around with the top one here, but the bottom one, this is gonna be our X, so which one goes for X? Well, it's not X, it's which one? It's points. That's the explanatory variable. The points should explain the response, which is Y, the win. So let's look. So we create a very nice scatter plot here for this. And so that's what we've done. We have created the scatter plot. There we go. Congrats, we did it. All right, so I'm not going to ask that you make a sketch of this. Just keep it handy while we're going through our notes. Of course, you can review this video, but I didn't have you write down the actual data or anything like that, so it should be fine. I think we get the idea. So we're going to draw a line in your notes. We're going to talk about describing scatter plots. Okay, describing scatter plots, and you can use this immediately in the problem set for sure. So to describe a scatter plot, we're going to follow the basic strategy of data analysis from chapters 1 and 2. We're looking for patterns, we're looking for departures. So we've got our data here, and we're looking at this pattern. So in any set of data for this, okay, I need to turn off the draw tool. Let's go home here. Okay. So this is the major. We're going to write these 2 bullet points, and we know what an outlier is, of course. You can describe the overall pattern of a scatter plot by the direction, form, and strength of the relationship. Okay. I'm going to add some bullet points in here. Direction, positive or negative. Okay. Form, for the form, linear. You could have quadratic, exponential, okay. So those are the different forms. I'm going to put commas in there actually. And in iMath 2, you should have definitely done some quadratic regression at some point. And then strength. Strength is something, for now, visually, we're going to get a way to interpret this. How well points fit pattern. Okay. So if we look at our, and then also outliers. So an outlier is an important time to departure, is an outlier, an individual value. So we don't even need this front part. Here, let me get rid of that. The individual value that falls outside the overall pattern of the relationship. We know what an outlier is. We've talked about that plenty of times. So when we look at this, we can start by saying, well, what's the direction? How would you describe that? Think linear, right? Because this is sort of making almost a line. Well, it looks like it's, and we think slope, right? Okay, so rise over run. And if you remember from middle school even, when it goes in this direction, it's a positive slope. So we have a positive relationship happening here. And positive means as one increases, the other's is increasing as well. All right, what's the form of it? Linear, quadratic, exponential, etc. It looks linear mostly, right? And a lot of what we're going to be doing in this chapter is linear. Okay, strong, how well the points fit the pattern. So we could say very strong, strong, weak, very weak, no relationship or no strength at all. Those are the different ways that we can describe that. And we'll look at a chart that to describe that as well. So that's in general how we're going to interpret a scatter plot. It's not too bad. It's not too difficult. Let's go to the next slide here. So we're still talking about describing scatter plots. So we talk about a positive association. It says when above average values of one tend to accompany above average values of the other, and when below average values also tend to go together. Okay, so that's sort of a weird way of saying that. Hold on a minute. I want to rephrase this. So we'll write this. Say as one variable increases, the other is increasing. Okay. Or both are decreasing. That's really what that's trying to say. Okay. Right. Okay. So we'll put that way. And so you're going to want positive association as the definition. Negative association. Let's talk about negative association. It says above average values tend to accompany below average values. That's just such a weird way to put that. We're going to, there's really only one way to put this. As one variable increases, the other is decreasing. So I just need this. There we go. That's how that works. So looking over here, as the explanatory variable goes up, okay, percent taking SAT, mean math score goes down here. I'm not really sure what the context is with this. But you can see here how they are describing it. There is a moderately strong negative curved relationship. So you're talking about the overall shape between the percent of students in a state who take SAT and the mean SAT math score. Okay. So the states that have fewer have higher scores. That kind of makes sense if you think about it. We force ACT in this state. If you ever take the SAT, you're probably a motivated student to go out there and take this other test, right? So it says further, there are two distinct clusters of states and two possible outliers that fall within the pattern. So you see this cluster here and this cluster here. So clusters are a big part as well of these data points. Okay. So this is very important: negative and positive association. Okay. All right. So looking at, okay, this is exactly our scatter plot right here. All right, so this is how they're describing it. So we talk about direction. So we would say positive association, and we had said that about ours. So this is that football example. There seems to be a linear pattern, okay? And then strength, because the points do not vary much from the linear pattern, the relationship is fairly strong. There are no outliers, all right? So that's the big ideas to start us off with these associations. All right, so we are now going to talk about probably the most important concept in this chapter, which is this, what's called this correlation coefficient. Okay, correlation R is what we call it. So when we're looking at these values here and we're saying, okay, there's a positive correlation within this data, and then we're trying to say, okay, well, how strong is this correlation, right? That was something that we wanted to decide here. What's the strength? How well the points fit in the pattern, right? They make this line. What is the strength? So when we're talking about this value R, we're talking about the strength of the relationship within that scatter plot. Okay. Probably going to wrap up the video here shortly, creating this R value for our scatter plot for this football, the SEC football teams. Okay, so we'll create an R value, our correlation coefficient. Okay, so the correlation coefficient measures not only the strength, which is what we really care about, but also the direction of the linear relationship between two quantitative variables. Again, it has to be quantitative here. So first off, R is always a number between -1 and 1, always. Before we write this, let's just go ahead and talk about how to find it. Okay, I feel like it's going to be better for us to like create one and then come back to these bullet points. I kind of like that a lot better. So let me make a new slide here. Creating the correlation coefficient R. All right, so once you've got your data in a scatter plot here, so first thing we want to do is type data in a list spreadsheet. Boom, done. Right, we've got that. All right, next, so we need to go back. So everybody on your calculators, go back to your list and spreadsheet right here. All right, once the data's in, go to a blank cell and run the linear regression. Okay, so how do we do that? That's going to be menu, statistics, stat calculations, and you can see linear regression right there. So menu, which one are we going to be using? 1 second. All right, so we're going to be using 4 here, linear regression. So it's we've normally, like when we go in the chat, it's 4, 1, 1, but this is 4, 1, 4 for this. Okay, 4, 1, 4. So menu 4, 1, 4. Create the linear regression. So we're going to click that. Set X list, explanatory, set Y list, as the response. Okay. So we know in here that, and we're going to do this on our calculator, we're going to do points per game is X, Y list is wins. Now nothing else needs to be done here. We're just ready. So go ahead and hit OK, and there we go. So we see a couple values, but this is the one that we want right here. So in our notes, let's go back. And we'll talk about, of course, all of these values in here, but find R, that is the correlation coefficient. Okay, cool. That is the correlation coefficient. So going back to this, and then we'll go back to our notes here with this, okay? This value is measuring the direction and strength of the line between these two quantitative variables. This is a linear relationship here. And based on the number we got, this 0.93, that is a really strong relationship. By the way, first bullet point, R is always a number between -1 and 1, okay? All right. So let's go ahead and talk about this. If R is greater than 0, it's a positive association. If R is less than 0, it is a negative association. So basically, if it's negative, it's a negative slope, right? Greater than 0, it's a positive slope, okay? Values of R near 0 indicate a very weak linear relationship. This is a super important one to keep in mind. So as it gets closer to 1 or -1, either direction, it gets strong, right? But if it's closer to 0, it's very weak, okay? Strength of the linear relationship increases as R moves away from 0 towards -1 and 1. The extreme values of -1 and 1 occur only in the case of a perfect linear relationship. So let's look at that. I want to show an example of that. Let me make a list here. We'll call this X and Y, and we are going to do. Oh, whoops. I'm going to say, okay, this is 1, 2, 3, 4, 5, right? And this could be just the function 2x plus 3. So this will be 5, 7. The change is 2 every time, so 9, 11, and this will be 13. So this is the equation 2x plus 3 that I've put in here. It is actually a linear function that you know from iMath. So we go in here. And wrong one. And I don't even need this. I just need to do the correlation. So menu 4, 1, 4. Change this to X, change this to Y, hit OK. Look at this value, it's R, okay? Now, as soon as I change it to go the other way, if I make it a negative slope, so -2, so this is 1, this is -1, 3, -5, -7. Look at the R value. What happened? Did I do it wrong? 2x, -2x plus 3, -2 plus 3. 2. Not really sure why that didn't update. Anyway, if it were a negative slope, it should work. I don't know why that's not working, but anyway, that's the idea. If it's a perfect linear relationship, this is extremely rare to occur in just natural data. It's almost impossible to occur in natural data. So you won't be seeing any exact ones or exact negative ones. Anyway, I'm going to go ahead and pause and let you guys write this down. And then we got a few more points. Okay, so let's go back here to this and about what will happen. Let me move this over. Actually, I want to delete that. We've got our scatter plot here, and what will happen if, let's say, this point here goes up. I still want it to be, I'm going to keep the X value the same, but I'm going to change the Y value. Let's say that this team won more games. So what's going to happen to this R value if I change this to a 13? Well, look how much it changed. It went from 93, we'll undo that, Control Escape, 93 point, oh wait. 93.57. As soon as I change this to a 13 and hit enter, it's going to hurt that relationship, right? So, and we go back to our points here. Let me redraw this. Let me just change that to this. And we'll see that this point went way, look how far up it went. There it is right there. It definitely went out of the pattern. So it does weaken that relationship quite a bit. So if it goes back to 8, it goes back to a stronger linear relationship. Okay, it automatically goes down, okay? What happens if, let's take a point that's kind of more out of the pattern. Let's take this one here. I think this is Kentucky here. And let's just reduce that 5 to a 4. So here's the 5, wait, which one? Right here, 5 to a 4. That, it increased it. So go back to 5, watch. So by changing this to a 4, it increases that R value right here to 95. And we go look at the graph. Yeah, it's forming more of a line, right? So hopefully that idea makes sense. We're gonna end the video here. I'm at 31 minutes. Let's stop it here. Hopefully that makes sense. You've got some good questions to talk about that with. Like question number 3 here, if the data point 6570 were removed from the study, how would the value of R change? So now that we know what that is, 6570, look at that. So this point's way up here. It's way out of the pattern of this overall graph with the volume of the tree. So that should help the R value. It should make the R value larger since it does not fall within the pattern of the rest of the data. So I kind of answered the question there, but hopefully that makes sense, and hopefully it's not too bad for you guys today. We'll stop it there and go ahead and start working on this problem set.